Hello and welcome to this video. In this video, we will resume the read through of Python uh, standard library. We are going through regular expressions and we were here. So the next special character which is in regular expression we encounter is the pipe. So A pipe B implies that where A and B can be arbitrary regular expressions. So A pipe B will create a regular expression that will match either A or B. An arbitrary number of regular expressions can be separated by pipe in this way. This can be used inside groups as well. As the target string is scanned, regular expressions separated by pipe are tried from left to right. When one pattern completely matches, that branch is accepted. This means that once A matches, B will not be tested further, even if it would produce a longer overall match. In the other words, pipe operator is never greedy. To match a literal pipe, use backslash pipe or enclose it inside a character class as in brackets. Next is triple dot inside parenthesis. Matches whatever regular expression is inside the parenthesis and indicates the start and end of a group. So this is called grouping of regular expression, and the contents of the group can be retrieved after a match has been performed and can be matched later in the string with the number special sequence described below. So first group, if I remember, is called 1 and 2 and 3 and so on. To match the literal parentheses, use backslash before them or enclose them inside a character class, that is inside brackets. Next is question mark triple dot. This is an extension notation. A question mark following a parenthesis is not meaningful otherwise. The first character after the question mark determines what the meaning and further syntax of the construct is. Extensions usually do not create a new group. Question mark p name is the only exception to this rule following our currently supported extension. So the first extension is AI capital L M S U X. So one or more letters from the set A, I, L, M, S, U, X. The group matches the empty string. The letters set the corresponding flags for the entire regular expression. A will set ASCII only matching. I will set ignore case. L will set locale dependent. M will set multi-line. S will set dot match as all. U will set Unicode matching, and X will match verbose. So we will see the description of all these flags later on. This is useful if you wish to include the flags as part of the regular expression instead of passing a flag argument to re.compile function. Usually we pass these flags into re.compile function and we don't use this, but you can use this also. Flags should be used first in the expression string. So that is, they have to be used first. Next is colon after question mark. A non-capturing version of regular parenthesis matches whatever regular expression is inside the parenthesis, but the substring matched by the group cannot be retrieved after performing a match or reference later in the pattern. Then we have the same AILM-SUX minus IEM-SX. So in this case, what it does is 0 or more letters from the set AILM-SUX followed by minus followed by 1 or more letters from IMSX. The letters set or remove the corresponding flags for the part of the expression. The letters A, L, U are mutually exclusive. That is, you can't use A, capital L and U. ASCII only matching cannot be used with locale dependent or Unicode, and it is true for others also. So these are mutually exclusive when used as inline flags so they can't be combined or follow minus. Instead, when one of them appears in an inline group, it overrides the matching mode in the enclosing group. In Unicode patterns, question mark A switches to ASCII only matching, question mark U switches to Unicode matching. In bytes pattern, question mark L switches to locale dependent matching and question mark A switches to ASCII only matching default. The override is only in effect for the narrow inline group, and the original matching mode is restored outside of the group. Then we have question mark greater than. Attempts to match triple dot, that is the regular expression we have, as if it was a separate regular expression, and if successful continues to match the rest of the pattern following it. If the subsequent pattern fails to match, the stack can only be unwound to a point before the question mark greater than, because once exited, the expression known as an atomic group has thrown away all stack points within itself. Thus, question mark greater than dot star would never match anything, because the first dot star would match all characters possible. Then, having nothing left to match, the final dot would fail to match. Since there are no stack points saved in the atomic group and there is no stack point before it, the entire expression would thus fail to match. Then we have question mark P and followed by name. Similar to regular parenthesis, but the substring matched by the group is accessible via the symbolic group name. So in this case, the group, as I said, it is named 1, 2, 3. In this case, that group will be available via this name. Group names must be valid Python identifiers, and in bytes patterns, they can only contain bytes in the ASCII range. Each group name must be defined only once within a regular expression. A symbolic group is also a numbered group, just as if the group were not named. Named groups can be referenced in three contexts: if the pattern $P quote followed by brackets with quotes dot star question mark P is equal to quote, that is matching a string quoted with either single quote or double quotes. So the context of reference to group quote in the same pattern itself is like this. So as I said, it is \1 or \2, you can do it. When processing match object M, so M dot group quote, M dot end quote, etc. in a string passed in the REPL argument of RE dot sub. So in this case, \G quote, \G1 and 1 are used. Then we have question mark P is equal to name, a back reference to a named group. It matches whatever text was matched by the earlier group named name. Question mark hash, a comment, the contents of the parentheses are simply ignored. Question mark is equal to matches if triple dot matches next but doesn't consume any of the string. This is called look ahead assertion. For example, Isaac space this question mark is equal to Asimov will match Isaac only if it is followed by Asimov. Question mark not triple dot matches if triple dot does not match next. This is a negative look ahead assertion. For example, Isaac question mark not Asimov will match Isaac only if it is not followed by Asimov. Question mark less than triple dot matches if the current position in the string is preceded by a match for triple dot that ends at the current position. This is called a positive look behind assertion. Question mark less than is equal to ABCDEF will find a match in ABCDEF, since the look behind will back up three characters and check if the contained pattern matches. The contained pattern must only match strings of some fixed length, meaning that ABC or A or B are allowed, but A star and A3, 4 are not. Because A star is not a fixed length string. It can be 0, 1, 2, 3, 4, anything. Any number of characters are possible in this case. And in this case, the length is not fixed. The length can be either 3 or 4, so it is not allowed. But in this case, ABC is of length 3 and A or B is of length 1. So only of fixed length strings are allowed. Note that patterns which start with positive look behind assertions will not match at the beginning of the string being searched. You'll most likely want to use search function rather than match function. So for example, if we search this and this is our regular expression and we have A, B, C, D, E, F, the group is def. Okay, the group we find is def. Now, the example, if you want to look for a word following a hyphen, so we are looking for minus here, okay, and then W plus. So in this case, the minus will be matched and then egg will be matched, okay. Question mark less than exclamation mark triple dot matches if the current position in the string is not preceded by a match for triple dot. This is called a negative look behind assertion. Similar to positive look behind assertions, the contained pattern must only match strings of some fixed length. Pattern with which start with the negative look behind assertions may match at the beginning of the string being searched. Question mark ID/name yes pattern or no pattern. We'll try to match with yes pattern if the group with given ID or name exists, and with no pattern if it does not. No pattern is optional and can be omitted. For example, question mark, in the parenthesis less than question mark, in the parenthesis backslash w plus at the rate backslash w plus parenthesis left parenthesis question mark colon backslash dot backslash w plus right parenthesis plus right parenthesis left parenthesis question mark the first group, that is this less than matched by this greater than pipe dollar is a poor email matching pattern which will match less than user. So user is matched by this, okay, and backslash w plus, so that will match host, and then we have dot, okay, and then we have com which is matched by this w plus. So now you know that this can repeat many times, okay. In case of subdomains, for example, if you look at my email for my Kunjika website, it is shiv@kunjika.ashtavakra.org. So this pattern here can repeat here. Okay, first W plus is mandatory. The dot and the word can repeat. Okay. So this will match this as well as user@host.com. Okay. Because this can come or this question mark is 0 or 1. All right. That is why it can match less than or it matches the email address, but not with less than user.com @host.com or nor user@host.com greater than. So you see what is happening here is we have question mark and we have something here, okay, username @something, okay, and then the domain and the yes pattern and no pattern. If you see here, so this is the yes pattern, okay, and this is the no pattern. So yes pattern is greater than and no pattern is empty. So it will, if this is present, then this must be present. Otherwise, both must be absent. Okay. The special sequence consists of backslash and a character from the list below. If the ordinary character is not an ASCII digit or an ASCII letter, then the resulting RE will match the second character. For example, backslash dollar matches the character dollar. So the first sequence is backslash number, matches the contents of the group of the same number. Groups are numbered starting from 1. For example, dot plus in bracket backslash 1 matches the or 55, but not the without space. Note the space after the group. This special sequence can only be used to match one of the first 99 groups. If the first digit of a number is 0 or number is 3 octal digits long, it will not be interpreted as a group match. But as the character with octal value number inside inside the brackets of a character class, all numeric escapes are treated as characters. Backslash capital A matches only at the start of the string. Backslash B matches the empty string but only at the beginning or end of a word. This is called also as word boundary. A word is defined as a sequence of word characters. Note that normally backslash B is defined as the boundary between a backslash W and backslash capital W. Here backslash W, small w is matches alphanumeric characters and backslash capital W is non-alphanumeric characters, or vice versa, and between backslash W and the beginning or end of the string. This means that regular expression backslash BAT backslash B matches at, because this is the word boundary, at dot because dot is also a word boundary, but at inside parenthesis because this is a word boundary, parentheses are word boundary, and as at AY but not attempt or atlas, okay, because in this case at would be a space here between as and at and AY space will create a word boundary, okay, but in this case after at T comes which is not a word boundary and here L comes. The default words in Unicode str patterns are Unicode alphanumerics and underscores. But this can be changed by using the ASCII tag. Word boundaries are determined by the current locale if the locale flag is used. Inside a character range, \b represents the backspace character for compatibility with Python's string literals. \B matches the empty string, but only when it is not at the beginning or end of the word. This means that R at \B matches Athens, atom, attorney, but not at dot, or at exclamation. \B is the opposite of \B, so word characters in Unicode str patterns are Unicode alphanumerics or the underscore. Although this can be again the same thing. \D is for digits. For Unicode, str patterns matches any Unicode decimal digit, that is, any character in Unicode character category. This includes 0 to 9 and also many other digit characters. Matches 0 to 9 if the ASCII flag is used. For 8-bit bytes patterns matches any decimal digit in the ASCII character set. This is equivalent to 0 to 9. \D means non-digit characters. Okay, so that's the same thing. \S is space characters, white space. Okay, these white space characters are defined by edge space. This includes tab, new line, carriage return, form feed, and vertical tab, and also many other characters. For example, the non-breaking space mandated by typography rules in many languages. So, for example, white space is also included in this one because the simple space bar is there. So it's the same thing for 8-bit byte patterns. \S is non-space characters. So for example, it is which is opposite of S. So if these characters are not there, then it is capital S. \W is word characters. So it is defined by is alphanumeric. So whatever is there, it will be included. So A to Z, small a to Z, capital A to Z, 0 to 9, and underscore. For 8-bit byte patterns, the same thing. \W is negation of what was there for small w. \Z matches only at the end of the string. Most of the escape sequences supported by Python literals are also accepted by regular expression A, B, F, and these are all the escape sequences. Note that \B is used to represent word boundaries and means backspace only inside character classes, that is inside brackets. \U, capital U, and \N escape sequences are only recognized in Unicode patterns. In byte patterns, they are errors. Okay. So I think I'll stop here, and in the next video, we will cover this module contents and examples and other things. So we should be able to cover these two topics, functions and these functions, and the module contents I will cover in the next video. We are almost at 40%, so probably in 2-3 videos we should be able to cover rest of the content, and then we will look at the examples. Okay, so if you can buy the book which was recommended in the section. If you can buy this book, Mastering Regular Expressions. It's a very nice book. I had the hard copy, but which I have gifted. So I don't have access to this book anymore. But if you want to read yourself, then you can buy it. Otherwise, just stick to the videos and we will go through all the almost all of the book will be covered here, whatever is in the book. Okay. So I hope that you are finding this read through useful and informative for yourself. Let me know in the comments what do you think about the read through kind of videos. If you don't enjoy and find it useless, then probably I will not make it. But if you think it is useful and find informative, because I think read throughs, what it does is you normally you miss the finer points of a topic, but when you read the documentation thoroughly, those finer points come out, and that's why I like to do read throughs. So let me know what you think in the comments, and thanks a lot for watching. Happy programming.